In this particular video, we're going to have a discussion on how to do parametric differentiation, and we shall also have some question to do with implicit differentiation. So this is A-level math P3 topic that we are going to focus on. The first thing we're going to do here is to write the first equation, parametric equation, the way it is, and this is x is equals to, we are given 2t plus sine 2t. So that's the first parametric equation, and the second parametric equation is given as y equals to 1 minus 2 cos 2t. So in order to differentiate these two parametric equations, first we are going to work out differentiation with respect to t for x, and also then we follow by working out the differentiation for y with respect to t. So the first case here, we are having the x dt, and differentiating 2t, we are going to have actually 2, and differentiating sine 2t, first we need to differentiate the inner function, and that is going to be plus differentiating 2t, we are going to have 2. Then once you have differentiated that, you can now differentiate the sine function, and it's going to be cos, then you write 2t the way it's written like that. So dx dt has proven to be 2 plus 2 cos 2t, and then we need also to differentiate y with respect to t, and that's going to be differentiating a constant, we get 0, and then minus 2. Now differentiating cos 2t, first we need to differentiate the 2 that is there. So the 2 I've written here is this 2 that we have at the beginning, and then we now differentiate this 2t that is here, and differentiating 2t we are going to get 2. Then we now differentiate cos, and differentiating cos you are going to get negative sign, write 2t the way it was. So that is how you differentiate trigonometric function which are having 2 or any number in that. So this is minus 2 times 2 times sine 2t, and this is going to translate to 4 sine 2t. Now once you have those functions with respect to t, we are going now to say now dy dt is going to be equal to, how are we going to get rather we are going to find dx dt. Let me just write it properly here. Now our dx, okay, I think we need to slow down a little bit so that we can be able to continue properly. So we are finding dy dt, so we're going to say dy dt. In this question we're supposed to show that dy dx is equals to 2 tan t. So in order to find dy dx, we are going to say this is dy dx is going to be equal to dy dt times dt dx. So dt dx, we can get it from the reciprocal of this particular part, and dy dt already we have it at this given point. So we can be able to say this is going to be equivalent to 4 sine 2t times dt dx is actually going to be 1 over dx dt. So this is going to be 2 plus 2 cos 2t, and this is going to translate to 4 sine 2t divided by 2 plus 2 cos 2t. At this given point, what I can do, I can equally factor out 2 in the denominator, and then we shall have 4 sine 2t, which is going to be 2 into bracket 1 plus cos 2t, and at this level I can cancel this and I will remain with. So meaning this equation of ours can be written as 2 sine 2t divided by 1 plus cos 2t. Now since the question expects us to find the final answer as tan t, we are going to deal with these double angles that we have at this given point. We can write this as our dy we are having at this given point can be written as 2 sine 2t is actually the same as 2 sine 2t is the same as 2 sine t cos t. This part sine 2t, it can be written in this form here, and then we say divide by. Then also we can write 1 plus this cos 2t can be written as cos squared t minus sine squared t. Now, double angle can be converted to this form, and I need you to notice that at this point 1, we can be able to write in terms of trigonometric functions, that is cosine plus sine squared, cos squared plus sine squared. So this is going to be 2. Okay, let me just simplify the numerator. That is going to be 4 sine t cos t divided by 1 is the same as cos squared t plus sine squared t plus, now we add this part that you are having at this point, which is going to be cos squared t minus sine squared t. So the reason as to why we went that step is to ensure that we can be able to cancel this guy and this guy, and then we end up having 4 sine t cos t over 2 cos squared t. So this part and this part is going to cancel, and we shall remain with 2, and definitely we shall have 2 sine t cos t, and since this is squared, it means that this is the same as cos t times cos t. So at that point also we can be able to cancel out cos, and we end up remaining with this term, which is 2 sine t over cos t. So if you are having your dy dx being equals to 2 sine t over cos t, that implies that this is 2 tan t, and that's what we were supposed to show in this particular question. Now, moving down to the next part, we are supposed to find the value of find the x coordinate of the point on the curve at which the gradient of the normal is actually equal to that. So remember, in this question we have already obtained the derivative of or the gradient function, and then we are going to use that in order to work out the x coordinate. So let me just erase this so that we're able to move to part B. So if we are told the equation of the normal, suppose you have a curve that is like that. So if we are talking at a point, at this point where we have dy dx, a tangent to this curve has the same gradient as the gradient of the curve. So if we say this is the tangent, and a curve have the same gradient, and if we are talking of a normal at this particular point, it means the gradient of the curve or the gradient of the tangent times the gradient of the normal. So let's say the gradient of this one is m1 and this gradient is m2. So the gradient of the normal and the gradient of the tangent multiplied m1 times m2 is going to give us -1. So in this case, we are told we are finding the x coordinate of the point at which the gradient of the normal is actually 2. So meaning we can say 2 times the gradient of the curve is going to be -1. So the gradient of the curve is going to be -1/2. So we can now say we are going to equate this gradient to the gradient function of the curve. And remember, the gradient of the function of the curve was 2 tan t is actually equal to now this value that we have gotten here, which is -1/2. So it means tan t is -1/4. So implying that t is going to be the tan inverse of 1/4 negative. If we work out that, we are going to realize that our answer is going to be negative 0.245. This is going to be negative 0.245 as the value of t. Now, once we have the value of t, because we are finding the x coordinate, we are going to substitute that back to the parametric equation that we are given for x. X is equals to 2t plus sine 2t. So remember, this is the equation that we were given in the first place, and then we are going to substitute that and say that is 2 into negative 0.245, the value that we have gotten at this point, then plus sine 2 into negative 0.245. Now, if we substitute that and try to work out using our calculator, we're going to realize the answer we are going to get is actually negative 0.961. So if you try to work it out, you'll find that the answer you'll get is this. And we were supposed to give our answer correct to 3 significant figures. Now, moving to the next question. And if you're new to Provlan YouTube channel, consider subscribing so that in time we are going to upload more tutorials on the same, you'll be notified. Now let us go straight to the second question that we are going to focus here. And this question is actually a question whereby you are going to use implicit differentiation. And we're going to start by writing the equation the way it was. We are given the equation, and the equation is actually x squared into bracket x plus 3y minus y cubed is equals to 3, and then we are supposed to show that dy dx is equals to x squared plus 2xy over y squared minus x squared. So meaning that we are going to perform implicit differentiation and see whether we are going to arrive at this dy dx they are telling us. So number one, you need to understand here you are going to use product rule to differentiate this part, and here we are going, and anywhere in time you are going to differentiate y, because y is a function of x. You are going to say dy dx. Anytime you are differentiating y, you differentiate it normally, but you write dy dx after the expression you have obtained. So let us now focus on the differentiation of this implicitly. Implicit differentiation means that you are not going to rearrange this function so that you have x values on one side and y value on the other side. You are going to implicitly differentiate the values the way they are, the values of x and y the way they are, without rearranging them to have an explicit equation that has x and x on one side and y values on the other side of the equal sign. So here we are going to now start by saying, because we are going to differentiate this by product rule, it means we can decide and keep this constant and differentiate the other part. So we can say we shall keep x plus 3y constant, differentiate x squared, and this is going to be 2x. The next part on this, still on this first equation, we are going to keep x squared constant, and then we shall differentiate this part alone. So we shall keep x squared constant and then differentiate this. So differentiating this part, the first part will be actually 1 because differentiating x is 1, and differentiating 3y because y is a function of x, it means we are going to get plus 3, because differentiating 3y you get 3, but you have to write dy dx because you are differentiating y, and y is a function of x. Now we are done with differentiating this first part of this first term of the implicit equation that we are given, and then we're going to differentiate this. Differentiating this, we're going to take 3 down, and now this is going to be 3, and the power is going to decrease by 1. But since we were differentiating a y part, we are going to write dy dx at the end of it, and this is going to be equal to we are going to differentiate a constant, and this part is going to be. Now once we have done that, we are going to put those terms which are having the y together, and this is going to become, I can be able to open through and say this is going to be 2x squared plus 6xy. This is the first term, and then plus, if I open this bracket, actually going to have okay, no, this is going to be 3 at this point, like that. And then if I open the bracket, I'm going to have x squared plus 3x squared dy dx minus 3y squared dy dx is equals to 0. Now I can decide and take those terms which are having x on the other side of the equal sign. Yeah, so I am having also this term at this given point, and this is going to be added to this, and this is going to be 3x squared plus 6xy. This term is, these two terms are not having the y dx at any given point, then we shall say this is going to be also 3x squared minus 3y squared. I've combined this, and then I should write dy dx here is equal to 0. I'll take the whole of this term on the other side of the equal sign, and then we are going to remain with 3x squared minus 3y squared dy dx is going to be equal minus 3x squared plus 6xy over, we can divide both sides by 3x squared minus 3y squared, and this is going to be 3x squared minus 3y squared. This and this part will cancel out, and we shall remain with y dx is going to be equivalent to, I can decide and factor out 3 in both numerator and denominator, and I'll end up having 3 into x squared plus 2xy, and this part I'm going to remain with 3 into x squared minus. So if I decide actually to factor negative out, because the expression is not having a negative, so I can factor out negative 3, so that this negative is going to actually change some few things here, and because this term is having a negative, we shall have y squared minus x squared at that given point. So this one and this one is going to cancel, and finally our expression remains to be the way we are told to give it. We are supposed to have our expression equal to x squared plus 2xy over y squared minus x squared. Now hence we have shown what we were supposed to show in that case. Now let us try to check What is the next question that we are supposed to answer at this given point? Hence, find the exact coordinate of the 2 points on the curve. Find the x coordinate of the 2 points on the curve at which the gradient of the normal is 1. Just the question is almost similar to what we have done in the previous part. So the gradient of the normal is actually -1. So the equation of the normal is 1, meaning the gradient of the curve times the gradient of the normal, which is 1, is going to be -1. So that will mean to us that the gradient of the curve that we are talking about is going to be -1. So meaning this part that we have here as our gradient function is going to be equated to -1, the gradient that we have gotten at this given point. So we can say now x squared minus y squared, x squared minus, okay, this equation is not minus, but it's x squared plus 2xy over y squared minus x squared is equal to -1. So at that given point, we can be able to multiply by y squared minus x squared and also multiply y squared minus x squared on this other end, so that this part and this part will be able to cancel out, and we shall now remain with x squared plus 2xy is equal to x squared minus y squared. So you can see now here that these terms that we have at this given point here, x squared and x squared is going to cancel out, and we're going to remain with 2xy equals to -y squared. If we divide by y and divide by y both sides, we are going to have also y and y cancelling out, and that power is going to become 1, and therefore we shall have our x equal to -y over 2. Yeah, and I would like to write this equation as in terms of y. We can also say y is equals to -2x. Yeah, I would like it to be cleaner like that, so that I don't have to have fractions which are going to complicate matters a little bit in this question. Now, so we are going to find the value of find the exact coordinates of the 2 points of the curve at which the gradient of the normal is 1. So this value that we have gotten at this given point will be substituted to the original equation. We're going to substitute this into the original equation so that we can form a quadratic equation that we are going to form an equation that we are going to solve. Once we solve that equation, we can be able to know the coordinate they are talking about. Now, remember the original equation that we were given here was actually, the original equation was given as x squared. Let me just write the original equation. X squared into x plus 3y minus y cubed equals to the 3. This was the original equation that we were given, but we have now said our our y is going to be -2x. So meaning anywhere we have y, we're going to substitute this guy that we have here. So this is going to be x squared into x plus 3, but 3 is multiplied to now -2x, because we have said y is -2x. So we're going to multiply that minus 3 y cubed, but this is going to be now -2x now cubed is going to give us 3. Once we do this, we are going to simplify and say x squared into x minus 6x, and this is going to translate to, this is going to be actually -5x, Now negative 5x cubed, negative 5x cubed minus, this is going to be positive 8x cubed, and this is going to be equal to 3. And if we work out this, we're going to get 3x cubed equals to 3, and that means that x cubed is going to be equal to 1. So since we are finding 2 points, I can be able to say this equation can have three solutions. So I can say this can be written as x into x squared equals to 1. So what are the answers to this? We can say x is equal to 1, x equals to plus or minus 1. So which means the two values of x, because positive 1 is repeating itself, we're going to say that is going to be 1 or negative 1. Yeah, 1 or negative 1. So that means we have gotten the value of x being 1 or negative 1. And what will be the value of y? Y is actually negative 2x. So which means that we can say our y is going to be, when x is 1, we're going to say y is going to be negative 2 times 1, and that's going to be negative 2. So that coordinate is going to be 1, negative 2. And the second one, when x is equals to negative 1, y is going to be negative 2 x times the x value, which is negative 1, and that's going to be positive 2. So that coordinate is going to be negative 1, positive 2. So those are the exact coordinate of the 2 points on the curve at which the gradient of the normal is actually 1. Moving to the third question, and that okay, let me just move this from the vicinity so that we can be able to move that and work out that question very fast, so that you see what you are supposed to do at that given point. Now you're given the equation of the curve 3x squared, so let me just write it so that we can be able to work it out quickly. So we are given the equation of the curve here. The equation of the curve is 3x squared plus 4xy plus 3y squared is actually equal to 5. And we are supposed to show that dy dx is that. So we have already highlighted how to go about this. This one to be differentiated, it's going to be 6x, no, dy dx is when we have this. Then plus, we are going to keep 4x constant, we differentiate y. So we are going to say 4x is a constant. Then this is going to be dy dx. Again, plus, we are going to keep now y constant, we differentiate 4x. So this is going to be 4y. And because now if we keep 4x constant, or rather if we keep y constant, we are going to differentiate 4x. If you differentiate 4x, you are going to get actually 4. So that's why we are getting 4y, because y was kept a constant at that point. We differentiated 4, we got 4, then that 4 times y is going to be that. Then plus, differentiating this, we are going to say this is going to be 6y, but since we are having y, we differentiated y, we are going to say dy dx, because y is a function of x. So anytime you are differentiating a y variable, you are going to write dy dx because y is a function of x. And differentiating a constant, you are going to get 0. Now, the next thing you are going to do, we are going to put those terms which have dy dx, this one, together to this one, and this one we group them together. So we're going to say this is going to be 6x plus, this is actually from this point 4y, from this point, is 4y. Okay, yeah. So this is let us not mix things. 4x plus 6y is this. and 6x plus 4y is here, the one that we are taking out on the other side. So this is going to be 4y at that given point. And then the next thing we can be able to do is to divide 4x plus 6y, 4x plus 6y, so that this guy and this cancels, and we end up having the x is equal to negative what? We need to factor out what is common here is 2, and then we shall remain with 3x plus 2y. And on this point, we factor out 2. We're going to remain with 2x plus 3y. And we can be able to cancel this out. And our final answer becomes negative 3x plus 2y over plus 3y. So this is the expression that we were supposed to show as per this particular question. Now, once you have done that, you can be given a question like this. Hence, find the exact coordinate of 2 points on the curve at which the tangent is parallel to this. Now, if we are talking of a curve like this, and we have a point on the curve such that we have another line which is parallel to the tangent to the curve. So it means if this is the tangent and this is the line y equals plus 2x is equals to 0, it means from this line that we are given, we can be able to rearrange it and say this is going to be minus 2x uh, plus 0. So meaning the y-intercept for this line is 0. So this is y equal to minus 2x. It means that this line has a gradient which is negative 2. So if these two lines, this line and this tangent are parallel, it means also the tangent is going to have a gradient equal to negative 2. So the reason as to why we are given this line is to enable us know the gradient we are going to use actually in this particular question. So meaning we are going now to take this gradient negative 2 and equate it to this gradient, that function that we had gotten, so that we can be able to find the value of it. So here we are going to say therefore negative 3x plus 2y over 2x plus 3y is going to be equal to negative 2. So this negative will cancel out, and we shall have 3x plus 2y is equals to 2 into 2x plus 3y. And if we open the bracket and start putting things together, we are going to have actual 3x plus 2y equals to 4x plus 6y. And I can take this on the other side. We shall have 3x minus 4y is equals to 6y minus 2y. We end up having, this is 4x, 3x minus 4x. And if I take this on the other side, I'm going to have 6y minus 2y. And this is going to be negative x equals to negative 4y. Positive 4y, that is, and this is going to be x equals to negative 4y. So having gotten that particular part, we can be able to now see that all right, now we can be able to substitute whatever we have into the original equation so that we can get the values. We have x equals to negative 4y. Let's save this equation somewhere. And I need also you to look at and see the original equation that we were given is. So we are going to substitute this into the original equation. So let me just leave that part there, and then we try to substitute the value we have obtained into the original equation. So this is actually 3x squared, but x is negative 4y. So we're going to say 3 into negative 4y squared plus 4 into negative 4y because of this x then we shall have our y there, plus 3y squared is equals to 5. If we expand this, we are going to get, actually this is going to be 16, and we shall have 48y squared plus negative 16y squared, then plus 3y squared is equals to 5. So once we have this, we can be able to put the like terms together, and we are going to realize this is going to reduce to what? Of course, this is 48y squared minus 16y squared plus 3y squared equals to 5. And that means that this is going to be running to 32 plus 3y squared, and that's going to be 35y squared is equals to 5. Divide by 35 here, divide by 35 at this given point. We are going to remain with this cancelling out, and we shall have y squared equals to 1 over 7. To get y, we are going to find square root both sides, and we shall have our y equal to 1 over root 7. But remember, when you find a square root of a number, you actually have two answers. So that this is going to enable us find the two coordinates here, because if we are going to take our y be equal to positive 1 over root 7, and then our x is going to be what? Our x is going to be negative 4 times y, and our y is 1 over root 7. So meaning our x is going to be negative 4 over root 7. So the first coordinate can be written at this given point, and we shall say the first coordinate is going to be negative 4 over root 7, comma, our y in that case is 1 over root 7. That's the first coordinate, and that is the first exact coordinate. You don't have to find a square to that. And the other one is when y is equals to negative 1 over root 7. So our x is going to be negative 4 times the value of y, which is negative 1 over root 7. If you work it out, you realize that this part is going to be now positive 4 root 7. So that coordinate can equally be written as 4 over root 7, comma, negative 1 over root 7. And now that marks the end of this question, because we are supposed to write the exact coordinates of 2 points of the curve at which the tangent is parallel to the line y equals to 2x. Understanding? So the next question we are going to work out, we are told that just erase this. Equation of the curve is given by x squared y minus a squared y squared equals to 4a cubed. So let me just write that question so that we can leave out. X squared y minus ay squared equals to 4a cubed. And then we're supposed to show the first part that dy dx is equal to 2xy over 2ay minus x squared. So we are going to do this implicit differentiation the way we were doing in the previous question. And here we are going to use product rule because x and y are multiplied, and then we shall now start by keeping x squared a constant, and is going to be x squared. We differentiate y. Differentiating y, we're going to get dy dx plus, now again we can keep y constant, we differentiate x, so this is going to be 2x at that point. Now we are done with this equation. Then minus, now differentiating, because a is a constant, differentiating y, we're going to get 2ay, but since you are differentiating y, you must write dy dx, and I repeat saying that because y is a function of x, but since this part all of them are constant, we're going to get 0 there. Now we are going to say this is going to be 2xy plus x squared dy dx minus 2ay dy dx is equals to 0. But since we have dy dx, we can be able to factor out, and we shall say this 2y plus x squared minus 2ay dy dx is actually going to be equal to 0. So we shall take this guy on the other side of the equal sign, and we are going to end up having x squared minus 2ay dy dx is equal to minus 2xy. Then we can divide by x squared minus 2ay, divide by x squared minus 2ay, and that will mean that this part will cancel, and we shall have dy dx is equals to minus 2xy over. But now, since this term should be at the beginning according to the expression that we are supposed to show, we are going to introduce a negative, and then we shall say this negative 2ay minus x squared, because if you open this bracket, you are going to have this negative and it will go back to here. So once you have introduced that negative, so that you can be able to cancel with this, and the final answer is going to be dy dx is going to be equal to 2xy over 2ay minus x squared. And that is exactly what we were supposed to show as per question. Now, in the next part, hence find the coordinate of the point where the tangent of the curve is parallel to the y-axis. Now, if you have the two axes, this is the y-axis, and we have the x-axis, what you need to remember with this kind of question, x-axis has gradient is equals to 0, and the gradient of the y-axis actually is infinity. So it means we are whatever you are being told here is that the gradient of the function, because we are talking of uh, we are supposed to find the coordinates for the point where the tangent of the curve, the tangent to the curve. So if we were talking of tangent to the curve, suppose this is our curve, yeah, the tangent to the curve. Let me just try to illustrate that equation and say, if suppose this is the point that we are looking for, the tangent to that curve is parallel to the y-axis. If it's parallel to the y-axis, it means it's like the tangent is like this. Our curve is like that, and the tangent to the curve is like that. It's parallel to this. So meaning if the gradient of the y-axis is in infinity, the gradient of this tangent is also in infinity, then the gradient of the tangent and the curve are usually equal, then it means that also we are going to equate our dy dx is equal to infinity. So we are going to say 2xy over 2ay minus x squared is equal to infinity. Now, how will we have how can we be able to get infinity when you divide a function, maybe an expression 2xy, to get this? It means that this part is equal to 0. For you to get infinity answer, it means the denominator of this expression is equal to. So we are going to say 2ay minus x squared is actually 0. So that will mean that our x squared is equals to 2ay. Our x squared is 2ay. All right. So this given point, and maybe write our expression in terms of y, and we can now say maybe this is going to be y is equals to x squared over 2a, so that we substitute this value of y into the original equation so that we can be able to solve and get our answers. Just wait for a moment and see what we are going to do at this point. Now, since we have y is equal to x squared over 2a, which we got from this given point, so we are going to substitute this part that we have here into anything, anywhere you have y in the original equation, we're going to substitute x squared over 2a. So here we are having x squared, and then this is going to be x squared over 2a, because y is x squared over 2a, minus a into x squared over 2a, but that 2a is actually squared because y is squared here, is equals to 4a cubed. Let's see what we are going to get at this given point. Now, once we have that, we can be able to simplify this further and say this is going to be x power 4 over 2a minus, this is going to be x power 4 over 4a squared. But now, since there's this a is going to cancel with 1a, and we're going to remain with 4a, and that's going to be 4a cubed. So we are going to now multiply all through by 4a. I can multiply by 4a here, by 4a at this point, times 4a at this given point. This and this will cancel out, and this will cancel out. Of course, if this cancels out, we are going to remain with 2 at this given point. So we shall have 2x power 4 minus x power 4 equals to 16a power 4 at that given point. So this and this is going to simplify, and we shall have actually x power 4 equals to 16a power 4. That's all minus, this is going to be equal to plus all minus 2a. Now, since we have our x be equal to plus or minus 2a, but remember we had said our y is actually equal to x squared over 2a. So we can be able to find the coordinates, because we are asked to find the coordinate of the points where the tangent of the curve is parallel to the y-axis. So when we can now say, when x is equals to 2a, our y is going to be what? Is going to be 2a squared, 2a squared over 2a. Yeah, 2a squared over 2a. So meaning this is going to become 4a squared over 2a, and definitely this is going to simplify to this cancelling out. We shall have 2a at that given point. So the point here becomes 2a comma 2a, because the value of y and the value of x are 2a. So that point is going to be that. So we can also say, when x equals to negative 2a our y is going to be negative 2a squared from this point over 2a, and similarly we are going to be having 4a squared over 2a. This cancelling, we get 2, and this cancel with the power, we are going to get 2a again. So meaning also the point in that case is going to be minus 2a comma 2a. So those are the 2 points where the tangent of the curve is parallel to the y-axis. Moving to the last question, that is question number 5. Here we are doing parametric differentiation, and we are told that one of the parametric question is x equals to ln of 2t plus 3, 2t plus 3, and the second parametric question is actually 3t plus 2 over 2t plus 3. So in order to differentiate this, we are going to say this is dy dt, and this is going to be equal to, whenever you are differentiating ln, when you differentiate ln of x, you are going to get actually 1 over x. Yeah, but now you see we are having two functions. At this point we can be able to use u substitution. So in that case we are going to say the x dt is going to be equal to, differentiating this part, we are going to get 2 times. Differentiating ln, we are going to get 1 over 2t plus 3. And finally, our final answer becomes 2 over 2t plus 3. That is our dx dt. For this y, for us to get dy dt, remember we are going to use quotient rule. For us to differentiate this, we're going to say this is v. Quotient rule states that. Let me just write quotient rule first. If you are finding the of dx of two functions which are divided together, v u over v, this is going to be v du dx minus u dv dx divided by v squared. So that will mean that differentiating this, we are going to first let us work out our du dt. Okay, differentiate u first. If we are working out du dt, in this case we are going to use t because the parameter is t. We find the parameter is t in that case. So du dt is going to be, our u is the top part, is going to be 3, and dv dt is going to be 2. So this is going to be v du dt. Our v is 2t plus 3 times du dt, which is going to be 3. Then minus our u is 3t plus 2, dv dt is 2. Then divide by 2t plus 3 squared, and that's going to be equal to, this is going to be equal to 60 plus 9 minus 60 minus 4 over 2t plus 3 squared. And I can be able to see this, and this will cancel out, and I'm going to remain with 5 over 2t plus 3 squared. Now, once I have this done, and I have this done, we can now say dy dx is equal to dy dt times dt dx. So that you can see now we have our dy dt, which is going to be 2 over 2t. No, not dy dt. Our dy dt is this part, which is here. So that don't confuse that. So that we have 5 over 2t plus 3 squared times the reciprocal of this. Dx dt is this. So dt dx will be the reciprocal, and that is 2t plus 3 over 2. So you can be able to see that this part will cancel with 1, because we are having 2 of them is going to cancel with 1, and we end up having 5 over 2 into 2t plus 3. So with this expression we have this our dy dx, but the question states that find the gradient of the curve at the point. Find the gradient of the curve at the point. Let me just move this a little bit up. Find the gradient of the curve at the point where it crosses the y-axis. It crosses the y-axis. Find the gradient of the curve at which it crosses the y-axis. So we are saying if you have a curve crossing the y-axis, at the point where it crosses the y-axis, x is actually equal to 0. So meaning we're because we already have our equation dy dx at the point in terms of t, but we need to find the value of t, find t at x is equal to 0. So let us look at the parametric equation that we were given in terms of x is this one here. So we are going to say x is equal to ln of 2t plus 3, but at x is 0, we are going to say ln of 2t plus 3 is actually going to be equal to 0. In order to find the value of t at this point, we're going to find exponent both sides, and having exponent of ln into 2t plus 3 is equal to e to 0, and that will mean that this and this will cancel out. We shall have 2t plus 3 is actually equal to 1, and we shall take this on the other side. We shall have t is equals to 2t equals to 1 minus 3 divided by 2 divided by 1 at this given point, because 1 minus 3 you are going to get negative 2, divided by 2 both sides, this will cancel out and we are going to get negative 1. So that's why we're saying we are finding dy dx for this function where t is negative 1, and this is going to be 2 times negative 1, it will be negative 2 plus 3, and that's going to be 1 times 2, and then this becomes 5 over 2, and the final answer becomes 2.5. So the gradient of the curve at the point where it crosses the y-axis is 2.5. And if you have found value from this particular video, consider subscribing so that in time we're going to upload new tutorials, you're notified.